Okay, let's get started. Unit testing, let's do it. So, as always, I have the lecture channel open on Discord if you have questions, or the old raise your hand. But let's get into it. Unit testing. This is the first, I'd say the first 116 concept. The rest of the last 2 weeks was all just Java, but 115 content in Java. And Java has a few new things, the biggest thing probably being strong typing and type parameters, all this typing stuff. And a bit more syntax. The syntax I don't think is that big of a deal, but strong typing is probably the only concept that was new in the past 2 weeks. Other than that, it's review in a new language. This is the first brand new concept, and for the rest of the semester, it's all 116 concepts from here on out. So let's do it. I'm excited. In my eyes, this is where 116 really starts. The rest was just, hey, we have this new language that we're going to use. So my big question is, how do you know if your code is correct? And this is a question that will follow you throughout any software you write, throughout your whole careers if you're going to be a software engineer. How do you know if your code is correct? And there's kind of a progression that you'll go through to answer this question, and the ultimate end to this question is kind of unknown. It's up for debate. Every developer is going to have a different answer for this question that works best for their workflow. But everybody needs to at least consider this question. How do I know if my code is correct? And at least not be awful, not have an awful answer to this question. Like, I don't know, I'm just going to write code, and it's right because, I'm just great. That can't be your answer because you're eventually going to write bad code. So the first step in the progression in an academic setting where everything's, made up and pretend, and it's a nice cushiony environment, the very first thing you have that we give you is submit to Autolab. Autolab coughs up points, I'm good. Perfect. That works. For 115, this is fine. Some students even abuse this in 116, but it's a bit tougher to get away with in 116. But in 115, this ain't the worst thing to do, especially when you didn't do UB Infinite last semester. But you submit to Autolab. Autolab says you're good. You're good. And hopefully you all made it at least to the next step in the progression of running a main method. In Python, maybe you didn't actually explicitly write a main method, but hopefully you at least called your code and printed the results to the screen to make sure that it makes sense. Make sure the output makes sense on these inputs. So actually running your code, calling your methods, printing the results to the screen, and seeing if it looks right. It's a struggle in 115 to get students to that second step of the progression, but hopefully you all successfully got to that point where you can run your own code. Seems silly even saying it, like, you better have gotten there. But there are students who get through 115 without ever running their own code. It baffles me, but hopefully that's none of you. Hopefully you all got to this second step of the progression, which is, like I said, it's a struggle in 115 when it gets like halfway through the semester and I finally start seeing the majority of students in office hours actually running their own code. It's a good thing. It's a good feeling getting students to that point. Instead of just submitting to Autolab, Autolab said I'm wrong. Why is this wrong? Did you run your code? What? It's a struggle. 116, that should not be the struggle. You should all be there. But 116, we're going to push you to the next level of this progression of unit testing. This is similar to the running your main method and checking if the output is correct, but we're going to automate that process. We want to add automation to this. So we're going to write code that tests your code. This is our ultimate goal with unit testing. This is something that will live with us throughout this entire semester and hopefully your whole career. Devs notoriously resist unit testing, but hopefully it'll stick with you. It at least has to stick with you this semester because it's required, and next semester in 22250 because it'll be required. So let's talk about what this is. Hopefully forever. The students that it doesn't stick with and says, I'm not doing unit testing unless somebody's forcing me to do it, they're usually the ones who will complain about spending 40, 50 hours on a single 300, 400 level CSE assignment because they stopped doing testing because they weren't required to, and they just waste their entirety of their free time is spent on assignments because they haven't taken this lesson to heart. So I implore you, please, please. I see in 312 all the time students spending way too much time on homeworks because they didn't write one single unit test. Please just write your unit tests even when they're not required. While I have you this semester, I'm just going to force you to write them, so it's not that big of a deal now. But take this to heart. Try to internalize this concept and this lesson further in your career because it will save you tons of time, not just in other classes, but in your career itself. I'll stop and just tell you what it is now, but I just got to get that disclaimer out there because I see way too much pain in way too many students because they don't do their testing when it could save them tons of time. So what we want to do here is run a bunch of tests. We're going to code up tests, and these tests are typically going to be input-output pairs. I want to say I'm going to run my method that I'm testing on a particular input. I'm going to grab the output and check if that output was what I expected it to be. If it's what I expected it to be, good. If it's not what I expected it to be, that's bad. And we're going to code up all these tests, and if our code passes every single one of our tests, so on every single input we gave it, the code always returned the correct output, then we're going to say that code passed our tests. And if it did not, so if there's even a single test case, a single test where it didn't give the right answer, that code's wrong. This is just all or nothing. That's the way we like our code. We like 0 bugs. When you're using software, how many bugs do you want to see? 0, right? We don't want any bugs, so we want to pass every single test that we have. So you write up a bunch of tests, and you write your code. If your code passes all your tests, you're good. If it doesn't, you fix the bugs. You patch the bugs, and you keep patching bugs until you pass every single test. That's what we want. That's the standard we want to hold ourselves to. We need to pass on all inputs. We want every single test to pass. So here's our code, our first code that we're going to test, this absolutely wonderful method, very complex, high sophisticated code here. We're writing a method that takes an int as an input and adds 5 to it, returns that input plus 5. Yes, it's a stupid method. I know. It's something you would never, ever actually code. You would just add 5. But I want the method, the first method that we test, to be extremely simple. So the code itself isn't getting in our way. Every one of you understands this code right now. If not, no shame. I'll answer your questions still. You can do it anonymously in chat. I'll explain it. But I assume every single one of you knows what this code is doing. Even if you're still getting used to Java syntax, you can tell what this thing's doing. I would assume. If not, ask the questions. I'll be happy to go over it. But I don't want the code to get in our way because I want to focus on the unit testing. How do we know that this code is correct? And how do we write these unit tests? So here's the second step of our progression, the first one being submit to Autolab, and if Autolab says we're good, we're good. Second one is we're going to write a main method. We're going to call our method a bunch of times, print the results to the screen, and then verify with our eyeballs. Our human eyeballs are going to look at what's printed out. 7, 10, 6. Is that what I expect? Well, 2 plus 5 is 7. Cool. 5 plus 5, 10. 1 plus 5, 6. Cool. Looks good to me. Very manual process, though. We have a lot of work to do as a human in the process. What we want to do is automate this because it's not always going to be as easy as adding 5. We're going to have much more complex pieces of code and methods that we're testing, and it's going to be a lot more difficult to just write a giant main method with a whole bunch of tests. For example, we have a method that sorts hundreds of songs by title or artist. We can give it a different configuration to sort by title, different configuration to sort by artist, different configuration to sort by rating. And if we're testing this and printing hundreds of songs to the screen, I don't want to sit there and check that. Every time I change the code, check it to make sure it's correct with my human eyeballs. I'm not doing that. I would get a new career before I started doing that. That's crazy. I'm going to automate this. So we do. We write. That's why we write code, right? It's to do the work for us. So we want to automate this. So let's see this in unit testing. Let's get to that third step of the progression. Let's write this as a unit test. Now let's just go through this line by line. So this code on the left is our code that's going to test our code on the right. Let's talk about it. So we're going to use a library for this. You should have this library installed already when you clone the repo. IntelliJ is smart enough these days to know to install this library. There is a file called pom.xml in the code. You might have noticed that, you might not have. It works well enough these days that you can pretty much ignore it, and that's fine. But the pom.xml is going to specify what external dependencies we need to install. So this is the first library that we need that is external to Java, meaning this JUnit library that we're using does not come with Java. It's not part of Java itself. This is something we have to go out there, grab it, install it, or download it in our case, and then link it to our project. The pom.xml is used by software called Maven, which is a build tool. It's going to read the pom.xml, download the dependencies, link them to our project. It's going to do all that work for us. Those of you who had trouble getting Git working, there's always a handful of students every semester that do this. You have trouble getting Git working, and you can't clone the repo. Something goes wrong with that. So you say, well, you know what I'm going to do? I'm going to go to the repo. I'm going to download, copy and paste the files one at a time, or download the zip. Sometimes IntelliJ doesn't see that pom.xml in that case. So if you are having issues on this line right here, it'll say, I don't know what org.junit.test is, and you'll get an error on that specific line. If you're seeing that, look for the pom.xml, right-click it, and click Add Maven Project, or get Git working and clone it the way we recommend to do. Or if that pom.xml is missing, go to the repo, copy and paste that pom.xml, make sure you get that thing in your code, or else you're not going to have this library. But for most of you, this is just going to be automatic, and you won't have to think about this at all. But if you are having this specific issue, there's your debug process. Those are your debug steps. Okay, and then we're going to have another import. So we're going to import the test annotation, and then I'm also going to import the assert_true static method. You can import a specific method of a class using this syntax. I'm going to import a static method, the assert_true method, which is part of the assert class, which is in the org.junit package. I just realized that's a whole mouthful, but if you've been paying attention the last 2 weeks, that should all make sense. This should all be fairly clear, most of it. So some of that can still be fuzzy. I'd be okay with that. But we're importing this assert_true method, which lives in the assert class. The static says I want to import one method, not an entire class. Every other import we saw, import the array list and hash map, we imported the entire class. But if we just want one static method from a class, this is how we can do it. If you don't want to think about that, just paste this line in your code and then start using assert_true. And you don't have to think about it too hard. But that should make sense, mostly make sense to you. If we do import the whole class, if we just do import org.junit.assert, that's fine, but we'd have to do assert.assert_true, assert.assert_true. Just perfectly fine. Nothing wrong with that. But 116, I want to show you cooler things that save a little bit of typing. And then the test annotation. Very important to have this. Test annotation, this is what we imported in the first import line. The test annotation. And every time we write a method that we want to be treated as a test, we need to add this test annotation on the line before the test, before the method is created. This is going to tell JUnit that this method is a test. There's not going to be anything else about this method that's special that's going to say, hey, this is a unit test. Nothing about this class says this class is a unit test. The only thing that tells the JUnit library and tells IntelliJ that this is supposed to be a unit test is this test annotation. That's it. If that annotation isn't there, you don't have yourself a test. There's no test. So make sure you have this test annotation there. This is a very common mistake, at least for task one when you're first writing your very first unit test, is to miss this test annotation. If without that test annotation, you don't have tests, you'll submit to Autolab. Autolab won't see any tests. When you don't have any tests, it'll automatically pass everything. So it'll say pass on a correct solution and didn't test any features. And you can add as many test cases as you want. You're never going to see any different feedback than that if you don't add your test annotation, because none of your code's actually being ran. It's not being executed. So we need this test annotation. Just don't forget it. It has to be there. Then we're going to write a method. For what it's worth, this is not a static method. There's quite a bit going on. I'll wait till I have a slide that talks about it. I think it's the next one. But I'll wait for that one to talk about the rest. But for now, this isn't a static method. The method Give it any name you want, whatever you want to name it, whatever you want to name your method. So this method is a test because it has a test annotation, the @test, capital T, and then whatever you want to name it. In Autolab, it will give you some feedback about your individual test, specifically if a specific test is broken, if it's not testing the right thing, and it's just wrong, for lack of a better word. It's going to tell you which specific test method was wrong. So I recommend giving these meaningful names. Some of you will just do test 1, test 2, test 3, and I'm not going to stop you. But I do recommend giving these more meaningful names, and I do give you extra feedback in Autolab based on your individual test methods, so you can get some leverage out of those test names. But if you name them test 1, test 2, it is what it is. You're going to do what you're going to do. I got a lot of things, a lot of habits to try to get you to adopt. That one I'm just not going to die on that hill. And then finally, write our test cases. Our test cases for this test, we're using this assert true method. There's going to be a few different asserts that we're going to see starting Wednesday. We're going to see assert equals as well. For now, let's stick with assert true. This is going to take a Boolean expression, anything that resolves to a Boolean, and if whatever we give assert true is true, that test case passes. If we give it something that resolves to false, that test case fails. So anything you could write, you can think of this as a Boolean expression, if, and then some expression, passed, else, fail. That's what this assert true effectively is doing. So anything you can write as a Boolean expression, you can stuff inside this assert true and use that as a test case. And thinking back to Friday, we can use that or. So if the answer the method gave me was cat or dog, we can use that kind of syntax to check for multiple correct things. A lot we can do with this. A lot you can do with Boolean expressions, with all your logical operators. You can do a lot with this. But anything you can write as a Boolean expression, you can test with assert true. It is the most powerful assert. We're going to see assert equals, but it's more convenient in a lot of cases, but not quite as powerful as assert true, which leaves you to code whatever the hell you can code as a Boolean expression, and it'll test it. So if all three of these pass, then this test is going to pass. If even one of these fails, the whole test fails, which is what we want. Because we want perfection. If I have a method that adds 5, and with the inputs 2 and 5, it works fine, but with the input 1, it gives me like 17, I don't want to use that method. I want that thing passing on all my tests. So we do go for perfection here, as we should. Okay, this is a slide I want to talk about some more meta stuff. The method here, the class here, notice that the method isn't static, and there's no main method in this class. I told you every Java class has to have a main method if you want to run that as a program. But when you code this up, you put this exact code in IntelliJ or clone the examples repo where this exact class exists, you can right-click it and run it as though it had a main method. And there's no magic going on here. There kind of is a little bit of magic, I guess, but not real magic, obviously. But we're going to run this. And when we run this, what's actually happening is IntelliJ is smart enough to see that it has a JUnit test inside of it. And IntelliJ knows about JUnit and knows that it exists. And what it's going to do is go to the JUnit library. There's a test runner class that it's going to run, which does have a main method. And it's going to run it with our class. It's going to give it our class. And then the test runner is going to create an object of this add test type and then call the test add5 method through that object. So when I said we use static so we don't have to think about objects quite yet, the test runner class is going to worry about objects. It's going to do the whole object thing. So that's why the method is non-static. But we don't have to worry about that yet. You just have to remember to not put static in these test methods. And the test runner is going to worry about, oh, this is a non-static method. Test runner is going to handle all the details of that. So there is still a main method being executed. It's just not part of our code. It's part of the JUnit library that has the main method. And it's going to do all the overhead and all the logistics for us to get to what we actually want, is just running any method in our class that's annotated with @test. It's going to run that as a test case. And if any of our assert trues are given false as a value, then it's going to say this failed. And if they all are true, then it's going to say this passed. And then back to our question. First, I'll also ask while I'm saying this, are there any questions on this? This is the structure of a unit test. But I also have the question for you, is this enough testing? Let's go back to our first question. Is this enough testing? If we write code and it passes this test with these three test cases, and there's a lot of terminology here, test class, test method, test case, the class, the method, and then each time I have a line with assert, that's going to be a test case. So this test class, this test method, these test cases, are these three test cases enough? Any code that passes these three test cases, are we feeling good about that and saying there is no possible way any code that passes these three test cases could possibly be wrong? And are there any questions in general? I'll pause for a second and let y'all ponder that. If there are no questions, if everybody thinks this is enough testing, we just go home, right? That's enough testing. We got this. Of course, it's not enough testing. I hope that's just too obvious of a question. But since there are no questions about this, I'm going to assume everybody's good with the structure of a unit test, importing the library, using the assert true, the test annotation. I'm going to assume all that's good. So let's go on to no, this is not enough testing. We have three small positive integers. Like I can write an add5 method. Now again, this method is so simple. Like you wouldn't need any testing. You just look at this method and say, yes, that's right. God, why are you even testing this thing? But if you can't see the code, if you can only see the tests, and you're trying to convince yourself that the code, if any code passes that test, it has to be correct, are you convinced? If you can't see the code right on the screen? No. But I'm not convinced. I would not be convinced. So here's some code. If I just change my add5 method and change it just a little bit, I'm going to take the absolute value of the input and then add 5 to it. Well, this code is clearly wrong. It's not going to handle negative inputs. I don't know what would possess somebody to actually write this code, but if they did write this code, it's going to pass this test. Like this test is going to be like, yep, that code's good. The code is absolutely incorrect. But the test is going to say this is good, which is an indication that we don't have enough testing. We definitely don't have enough testing here. So what we're testing here is, I think I forgot to say it. We're testing what I'll call the common test cases. These are like common inputs. These are like the first inputs you're going to think of. Like let's just give it a couple regular inputs. These are the common cases. What we want to move on to are what I'll call the uncommon cases. This is where we got to stretch our brains a little bit and start thinking of what kind of crazier inputs can somebody throw at this thing that aren't necessarily the first ones that come to mind. Well, like the second ones that come to mind are going to be the negative numbers. So a few things here. I'm going to add some test cases for negative numbers. I'm going to add a few larger positive inputs in my other test. And I can use different methods. I can have different methods in the same test class. So here I have two test methods in the same test class, and each test method has multiple test cases. So quite a bit of terminology there, but hopefully a lot of it straightforward. You know this is a class. You know these are methods. The new one is these are test cases. So we're going to add our uncommon test cases, and if I submit this to Autolab, Autolab's going to give me separate feedback on test add 5 and test add 5 with negatives. So I do encourage you to separate them into tests. Some of you will have one test with all of your test cases. I'm not going to stop you, but if you come to office hours with an issue that could have been solved by splitting that up, you know what I'm going to say. I'm going to say, let's split this into multiple test methods. So we're adding these uncommon test cases, the negative inputs, which are usually things like negatives, very large numbers, very small numbers, the kind of strange things that your method might not see on most inputs, but your method will see these inputs from time to time. Sometimes users are going to enter, well, that's a bad example for this one, but sometimes people are going to use as their username something with like 57 characters. You want to make sure your code is still going to work in that case, or at the very least give them a message that says, hey, that username's too long, man. Tighten it up a bit. But we want to be able to handle those cases and do whatever the method should do, whatever we decide the method should do on these inputs, on these unusual inputs. And we're grouping our test cases together. There should be some logic behind how you're grouping them together. And then we have these test cases, and I'm going to ask, is this enough testing? So we have these test cases. We have this correct solution on top and incorrect solution on the bottom. And our tests are now doing their job. They're distinguishing between this correct and incorrect solution. The first test, it's correct solution. The first code, it's a correct solution, passes all of our test cases. Good. That should do that. We shouldn't be writing broken test cases that assert true adder.add 5 of 2 equals 100. We shouldn't be writing test cases like that. In that case, Autolab is going to say your test add 5 is busted. Fix your stuff. And then once we get beyond that, once our test cases are passing a correct solution, that means there's nothing completely broken with them, and we can move on to incorrect solutions. And do our test cases distinguish these, identify these incorrect solutions as appropriately incorrect? And our test cases, test add 5 says, yeah, this second method, it's good. There's nothing wrong with it. And when we get to our second method, and right from the first one, -1 equals 4, wrong. It's going to give us 6. It's going to fail that very first test case. And here's where we see the opposite of, we demand perfection and, our code has to be perfect. It has to pass all of our test cases. When we're trying to identify an incorrect solution, that works to our advantage. We only have to have one test case that gets rid of that incorrect solution. If we have one single test case for a specific feature that we're testing or a specific case of a feature, specific input, as long as we have one test case for that potential bug, we're good. We got that bug covered. Because any incorrect solution is going to fail that. If any solution with that bug is going to fail it. The bug here being doesn't work on negative numbers, or the feature is it has to work on negative numbers. We have 5 test cases that test that, so we're good. 5's greater than 0, we're good. And somebody writes this code because they're too smart for their own good, and they're like, here's my new code. And our test passes this, and this code is wrong. So we're going to say if x is positive, we're going to return the absolute value plus 5. Because it's positive, absolute value should just be the number. If it's negative, we're going to take the absolute value and negate it, and then add 5, because the negation of the absolute value should just be the original number and add 5 to it. And otherwise, we're just going to return x, because if it's not positive and it's not negative, it must be nothing, we're just going to return x. And you should definitely say to this person, dude, you were asked to add 5. Why are you even doing this? But some developers do this kind of stuff. They'll write code that's more complex than it has to be. And in these situations, what we like to have are the unit tests. We're going to run the tests and say, well, if our test passed that solution, I don't care how wacky you wrote it. I do care because I want to be able to read and maintain your code. But in industry, when you're working on a team, trying to release a product, as long as the test cases pass this code and my test cases are good and robust and answer the question, how much testing do we need? And I look at it and I say, that much. We need that much and we have that much, that we're good. Then your code can be all wacky like this, and I'll be fine with that. But this solution is incorrect. It's bad on the input 0. On 0, it's going to return 0. It's not going to add 5 to 0. So it is wrong code. But it passes our test cases, so our test cases are not enough. Let's add more test cases. So next we're going to check what's called the edge cases. Instead of saying alcohol, I mean, edge cases is a pretty common term out there. We're going to test the edge cases. These are the really strange cases, the cases that are usually have to be handled, I mean, not exactly in this case, but usually have to be handled with separate code. This is your usual, this is usually your 0, your empty string, empty array list, empty hash map, where sometimes you have to write extra code for this. In your average method, you have to have an extra line of code that says if the array list is empty. Actually, you don't necessarily have to. I shouldn't use that one as my example. Not for the large best key either. But there are methods that might take a data structure where you have to have an extra line of code that says if the data structure is empty, do something special with it. You can set up both those methods in a way where you don't have to have extra code, just carefully setting up your default values. But you usually have to have extra code, which means these are easy things to miss. It's easy to have bugs on the edge cases. So you want to make sure you have test cases for these edge cases. Make sure you're testing these. So we have our common cases, our uncommon cases, and our edge cases. Edge cases are something I'm always going to check in Autolab, making sure you have your edge cases. Make sure you have those. Those often end up being some of the first cases we think about as developers, just because we're so tuned to thinking about them. But we want to make sure we don't have any of those unique bugs at the edge cases. And when in doubt, write lots of test cases. We want lots of testing. So we have our common, our uncommon, our edge cases, and just lots of them. If you don't have enough testing, especially if Autolab's saying, hey, you don't have enough testing, or if you're not convinced that code that passes all these test cases must be correct, add more test cases. This is a good start for a test for testing for a test class, and for this particular method, this is fine. This would be enough testing. If this were a task in this course, this would certainly be enough to get through Autolab. Autolab would be like, yeah, you got all your bases covered. Like, you're good. But if not, just write more tests. If either Autolab's not good, or you're not convinced, or your coworkers aren't convinced, just add more tests. And the Autolab feedback will enforce this. If you don't have enough testing, it'll usually just say, maybe you should add more tests. And when I say add more tests, it's not just more tests. Volume isn't always the answer. Just adding more tests. Like if I go to my first test method here and just add a whole mess of positive integers, where it's positive integer, positive integer, positive integer, and I'm testing like 1 through 100, every single input, and you come to office hours, and without the next two methods, you just have the first one testing 1 through 100. You come to office hours and say, why isn't Autolab happy with my test? You said add more tests. I have 100 test cases here. What the hell, man? That's, sure, you got 100 test cases, but you're testing the same feature 100 times. So we want a nice variety. It's not just more test cases, but a nice variety of test cases is going to serve you much better than a lot of test cases that are testing the same thing. You could test this method pretty effectively with 3 test cases. As long as you have 1 positive, 1 negative, and 0, you cover most incorrect solutions, most bugs any developer could possibly write. Again, it's adding 5. Nobody's going to write a bug on this one. But when it's a more complex thing, you can do a lot of the good testing with just 3, as long as you have good variety. As long as you have a good variety of test cases. All right. Any questions on any of this? Yeah. Yeah. I would still call it an edge case. So the question is, if you don't have, I said an edge case is often something that you have to add extra code to handle. If you don't have to add extra code, is it still an edge case? I would still call it an edge case because it is a different situation that could have a bug. Because whether it actually took extra code or not is up to how you actually implemented the method. Somebody might implement the method where it needs extra code, or you might have set it up in a way where it doesn't. For the examples I gave, the average method and the best key, the two methods on the task 1 that take data structures, both of those do have those edge cases of empty array list, empty hash map as inputs. But depending on how you code it, you might not have extra code, but somebody else might. It's still an edge case because it still needs to be handled, and it's still an easy bug to write. Like, it's easy to write an average method that breaks when the array list is empty. For example, it's not really giving anything away because this is a 115 level question. Task 1, by the way, is all about writing your test cases for the methods. The methods themselves shouldn't be too hard to write. Sum of digits has a little bit of a twist to it, makes it a little tricky, but the average of an array list, nobody should be really struggling too hard on that. So I'm not giving anything really away here. But if you write your average of the array list, where you take the sum, you have an accumulator pattern set up, you take the sum of all the values in the array list, and then you return that sum divided by the list.size. That would be a way where somebody could write the code in a way that's going to have the bug on that edge case of an empty array list, because you're going to get a divide by 0 error in that situation. So somebody can write that. If you write your code in a way where it doesn't expose that, for example, you initialize your average to 0, and then each time, this would be kind of a weird way to set it up now that I think about it, but you initialize your average to 0, and you iterate over the list, and each time you read a value, you recompute the average based on that value that you read, and if the array list is empty, your loop never executes, and you just return 0. That would be a way where you wouldn't have any extra code, but you would still handle the edge case. And that's fine, but I would still call that an edge case because that case does have to be handled one way or another. It is a different situation. It has to be handled by your code, which can be extra code. It might not be, it might be, but. If your code you wrote already covers the edge case. Yeah, it's still an edge case, but your code might have just naturally handled it, and that's fine. If best key, you initialize a value to empty string and then loop through and update that initial value as you go. But if the hash map's empty, you just return empty string. That's a more clear example. You just return empty string because there was nothing to iterate over, your loop never executed, and you just return empty string. Yeah. No. So the question is, would you have to write an edge a test case for the input being the wrong type? No. You also won't have to write edge cases for null. Whenever, like the average method and the best key, the methods we just talked about, they could both take an input of null. We're not going to test for that. We're not going to worry about that in this class. Technically, yeah, you probably should test for that. But I don't want to make it a requirement because it's just tedious. So wrong types and null. The wrong types won't compile anyway. So you wouldn't be able to run the test. You'll get errors. And then null, we're just not going to worry about it in 116. Until we get to linked lists, we will have to worry about that. We don't have to worry about it quite yet, though. Linked lists take null and actually make some meaning out of it. But don't have test cases where you give average an input of null. We're just not going to worry about it. It's, again, the edge case of edge cases. And the reason to not worry about that is we just have to add that to every single test. And it's something you don't have to think about, like you're not learning something new after you do that the first time. It would just be, oh, don't forget your null. Oh, you forgot your null. I just don't want to do that in this course. So a variety of test cases, much better than just a lot of test cases. I've had students do that before too. They'll have 40 test cases. They'll be like, I have 40 test cases. You told me to have more test cases. One of them, I'll never forget that. Well, I might forget it someday when I have dementia and stuff. But it was a student where we're doing locations on a 2D grid, and we're computing paths from one location to another location. Locations were XY integers, XY pairs. And they had 40 test cases. They're like, you said add more test cases, add more test cases. And every single test case they had went in the positive X and positive Y direction. So they're like, find a path from 1, 1 to 2, 2, 1, 1 to 1, 2, 1, 1 to 2, 1. Everything was either no change in no dx dy or positive dx dy. 5, 5 to 10, 10. Every single test case was that exact thing. I'm like, well, how do I know your code can move in a negative direction if you've never tested that? They didn't have a single test case for that. They're like, I have 40 test cases. Yeah, but there's no variety. Every one of those 40 test cases was testing the same damn feature, the same damn functionality. And their code actually had a bug. It didn't go in the negative direction. So when they wrote that test case, they actually failed that test case, then had to patch the bug. And then they got on their way after that. But variety of test cases, think about all those edge cases. And variety of testing. Those weren't even edge cases. Those were uncommon cases, but variety. Testing in 116. All right. So when you submit to Autolab, you're going to see all kinds of feedback. I have some of this description on the Task 1 document itself of explaining what this is, but there's always questions about this. And I did update the output, the format of the output this semester to hopefully make it much less confusing than it used to be. It used to be, I don't know, more confusing than it had to be. I'm hoping it's more clear this semester, but if not, maybe I'll go back to the old way. But I think it's going to be better. So when you submit your code, every task is going to have testing and code. It'll have a testing component and a programming component, where testing is write test cases for all the stuff you're about to code, and then the coding component is just implement the stuff that you just tested. Most of the coding section is one line. It just says implement the methods that you tested above. So you're writing tests for your code and then writing the code itself. So Autolab, the first thing it's going to do is test your tests. So it's going to check your tests and make sure that you have good testing. And the first step of that, it's going to happen in 2 phases. One, it's going to run your test on a known correct solution. So it takes your test, gets rid of your code, replaces your code with my code that's known correct, and runs your test. Now, your test should say, yes, that is correct code. So your tests have to pass on a correct solution. So when you see passes on a correct solution, that's what's happening. Taking your code out, putting my code in, and running your tests on my code. If it doesn't pass my code, then there's something wrong, fundamentally wrong with the tests themselves. For task 1, the most common thing is the cat-dog thing, the multiple best keys, and only accepting one of them and not doing the OR thing. That's why I spent time on Friday talking about that one. It's the most common thing that I see on task 1 of failing a correct solution. So make sure you have that. If not, it'll give you a breakdown of each test name that you submitted and tell you which ones passed and which ones failed a correct solution. So that's phase 1, on a correct solution. Then your test is going to be ran on a series of incorrect solutions. I changed the feedback to not talk about incorrect solutions at all, but this is what happens under the hood, is I'm going to swap my correct solution out for a whole bunch of incorrect solutions, and your test should correctly identify each one of those as incorrect. The feedback is going to specify this as features. I'm going to say, do you have a test case for this feature? Yes or no, and then it's going to say whether you tested that feature or not. So you need test cases for each feature that's tested. The way I'm checking that behind the scene is with incorrect solutions, running your tests on an incorrect solution which has a bug in that feature, and then making sure your test can identify that as incorrect. So testing all the features. So is your testing correct? Does it pass a correct solution? And if it is correct, you're going to see the next phase of feedback, which is your testing enough stuff? Does it test all the features, or at least all the features I thought of when I wrote the grader, which isn't always comprehensive. For the first few tasks, it's mostly comprehensive. It's going to be most of the features that need to be tested. But as we go throughout the semester, I'll pull back on that, where you can pass your testing. Autolab can say your testing's fine, but your code is actually broken. Question? It'll tell you what feature, yeah. So it'll be a list of features. Did you test this feature, this feature, this feature? It'll tell you which ones you did test and which ones you didn't test. So that'll give you a clue as to what test cases to add. And then, oh, did I not even put it here? I guess because it's the testing lecture. But then the third step is taking my test and running it against your code to make sure your code is actually correct. So it's going to be ran against my test suite, which is going to be all kinds of tests. I'm going to throw all kinds of crap at your code and make sure it always gives the right answer. And a few things about testing. True, very versatile. I mentioned this earlier in the lecture. I don't know how much I have to reiterate it here. But very versatile, can do anything you ever want it to do. There's also assert equals, which takes two parameters, or two arguments, and passes if those things are equal and fails if they're not. We'll talk about this more Wednesday on the next lecture. And hint strings. You can give any assert call a string as its first argument, and then whatever other argument